The deep ocean is home to some of the most bizarre and alien-like creatures on Earth. From squid that look like vampires to creatures that resemble goblins, deep-sea animals are unlike anything we've ever seen. Stay with me now. We're going to take a look at the most bizarre creatures ever found in the ocean. The deep ocean is one of the least understood ecosystems on Earth, mainly because it's so remote, and it's too extreme and hostile for most forms of life to exist. These conditions, which are caused by the lack of sunlight, the intense pressures, and relative lack of food, pose unique challenges for survival, and has meant that creatures that do live there have to evolve highly specialized adaptations. The main influence on life in the deep ocean, compared to nearer the surface or on land, is the darkness. The first 200 meters or so you go down is called the euphotic zone, which is lit by sunlight, but beneath there things begin to get murky. Between that and 1,000 meters is the twilight or dysphotic zone, where there's far less light. And then beneath there is the aphotic zone, vents or in cold seeps are the main producers, converting chemicals like hydrogen sulfide into energy, which is a process known as chemosynthesis. As light is non-existent, many deep-sea organisms have developed ways to navigate using alternative means. Some have large, sensitive eyes that have adapted to detect bioluminescent signals, while others, such as certain species of fish, have completely lost their eyesight and rely instead on other senses like smell and vibrations. Bioluminescence too is an amazing adaptation to this lack of light, and around 90% of deep-sea creatures are thought to produce their own light through that process. This is used in a number of different ways, from attracting prey to deterring predators and even finding mates. The high pressure in the deep sea has had a major impact on the physical structure and physiology of deep-sea creatures, as at the greatest ocean depths, pressure can be more than 1,100 times that of the surface, which produces an environment where traditional skeletal structures would just be crushed. Some species grow to much larger sizes than would normally be expected. Thought to be a result of the cooler temperatures, the fact that there aren't as many predators to worry about, higher levels of oxygen in the water, and various other reasons, this has led to a number of peculiar and frightening discoveries. It's because of these reasons then that deep-sea creatures can seem so otherworldly compared to what we're used to, and in effect, they do live in a very different world than us. It's time to meet some of the strangest of all. Let's take a look at the vampire squid. This is a frightening deep-sea creature that looks the way it does because of a number of adaptations. Its Latin name translates to mean vampire squid from hell, but in many ways this is an unfair reputation. They typically live at depths between 2,000 to 3,000 feet, or about 600 to 900 meters, where oxygen levels are extremely low. And there's barely any light. The vampire squid survives in this habitat by slowing its metabolism and using hemocyanin, which is a copper-based molecule in its blood. When threatened, the vampire squid uses a defense mechanism called pineapple posture, where it can actually turn itself inside out and display this webbing to make its body appear larger and more dangerous. At the same time, it reveals spiky formations on the underside of its arms, giving it an intimidating look without any actual risk of aggression. Now, unlike true squids, the vampire squid doesn't have ink sacs for defense, and instead it releases a cloud of bioluminescent mucus that's filled with tiny, glowing particles to confuse predators. These vampire squids don't actively hunt prey and instead are passive feeders, mainly surviving on a diet of marine snow. To capture this material that falls from higher parts of the ocean, they have two long retractable filaments covered with mucus that particles stick to. Also, the bioluminescent ability of the vampire squid go far beyond just defense. Its body is covered in these light-producing organs called photophores, which emit a faint blue-green glow. This serves multiple purposes, such as camouflaging the animal against faint light from above, 16 inches or 40 centimeters, with some rare individuals growing even larger. They're found mostly in the deep Atlantic, Pacific, and Indian Oceans at depths between 500 to 7,000 feet, or about 150 to 2,100 meters. At those depths, food can be extremely scarce, so they have to develop slow metabolism and impressive fasting abilities. They can go for long periods, sometimes even years without food, and they're known to eat massive amounts when a meal is available. This feast or famine lifestyle is an important survival strategy for these scavengers, allowing them to cope with the unpredictable availability of food. Now, their segmented armored exoskeleton provides protection from predators and environmental pressures in the deep sea. Their bodies are divided into a number of overlapping plates, which allow them to curl up into a defensive ball when threatened, similar to how a pillbug behaves. This defensive shape protects their soft underparts from potential threats, making them difficult to attack. Their coloration, which is advantage of slow-moving or weakened animals that they come across. They are one of the few creatures in the deep-sea ecosystem that can consume large amounts of carrion and other materials like this, making them an important part of recycling nutrients and maintaining the ocean floor's ecological balance. Now we're going to take a look at the goblin shark. This bizarre-looking shark is certainly one of the most unusual species of shark. It's known as a living fossil. This is a deep-sea predator that's remained mostly unchanged for millions of years, dating back to a lineage that first emerged around 125 million years ago. Its strange appearance, particularly its elongated flattened snout, needle-like teeth, and strange jaw mechanism, make it very different to the sharks that we find closer to the surface. Living in deep water, usually between 900 and 4,300 feet, or about 270 to 1,300 meters, they're thought to swim in the oceans around the world, but seem to be more common off the coast of Japan, where the species miss out on it because it could be a long time until there's another chance, and this is why their jaws look so strange. Unlike most sharks, the goblin shark has a highly protrusible jaw that can extend forward and allow it to attack a target with unbelievable speed. When the shark detects potential prey, it shoots out its jaw in an outward motion, almost like an elastic spring, and this snaps shut over its prey with needle-like teeth that can hold on tightly to slippery animals. The speed and force of this jaw are made possible by specialized ligaments that store and release energy as the jaws open, which creates a vacuum that pulls prey directly into the shark's mouth. Awesome! Energy conservation down there at such depths is hugely important too, so goblin sharks are relatively slow-moving and rely on a stealthy approach instead of speed. Unlike fast-moving predatory sharks, goblin sharks have soft, flabby bodies with small fins, and it's thought that they will simply drift up close to their prey before relying on their fast jaws to finish the job. There is, though, a lot that we don't know about them. Because of the deep jaws and a bioluminescent lure, there's around 320 known different species, each of which lives in a slightly different environment, but all of which are aggressive carnivores. Most are found in the deep sea, but some can be found in shallower waters, instead blending in with rocky environments where they can remain camouflaged. Now, their most well-known feature is that bioluminescent lure that dangles from their head. This fishing rod structure is called an iliceum and extends from the anglerfish's dorsal fin, before ending with a glowing tip that's known as the esca. The light in the esca is produced by a symbiotic bacteria that live in that specialized organ and create a blue or green glow. This lure serves as a highly effective hunting tool, attracting smaller fish and other prey in the pitch-black depths. And when curious creatures approach the light, mistaking it for a smaller, easier meal, the anglerfish strikes, capturing its prey with powerful inward-facing teeth. They've got large, flexible jaws that can extend to swallow prey meters long, but the males are just a tiny fraction of that. When a male finds a female in the ocean, he immediately attaches himself to her body and then fuses to her skin and bloodstream through an irreversible process. Over time, the male essentially becomes a parasite, drawing nutrients from the female and providing gametes whenever she's ready to reproduce. Most female anglerfish will end up with several males attached to them in this way, making certain that they'll always be able to reproduce when they're ready. It is a grim but important process that's developed, as the deep ocean is so empty that there's virtually no chance they'd ever meet up with a mate during their fertile window if things worked in any other way. Alright, how about the Japanese spider crab? I don't like this one. This is an incredible example of deep-sea gigantism and is the largest known species of arthropod on Earth. They can grow to have leg spans of up to 12 feet or 3.6 meters from claw to claw, with surprisingly small bodies at the center being much older than 100 years, making them one of the longest living creatures in the ocean. The crab's enormous size is an adaptation that helps it survive in the challenging environment, with long legs that allow it to cover areas in search of food while using very little energy, which is vital for survival where food's hard to find. Their scavenging is crucial in the marine ecosystem as they help recycle nutrients by consuming matter and maintaining the cleanliness and balance of the ocean floor. Their habitat means that we don't know all that much about their behavior, but there is one particular thing that they do that's strange for animals as big as them. Although their size provides some defense, they're not immune to attacks from larger predators like octopuses, so to avoid detection, they use their claws to pick up seaweed, sponges, and other debris from the seafloor and attach it to their shells, which help them to camouflage and blend into their surroundings. This type of camouflage, which is called decorating, is something that's seen elsewhere with smaller crab species, but it's rare for a creature as large. They live in some of the deepest parts of the ocean, depths ranging from over 650 to 16,000 feet, or 200 to almost 5,000 meters. And living in such extreme depths where sunlight doesn't reach, they've adapted to the low-light environment with several unique features that help them survive. Their dark coloration provides excellent camouflage, meaning they blend in with the surrounding darkness. Hunting, of course, relies on those ridiculously large teeth, which are so big that they hardly even seem to fit in their mouth. In fact, the teeth are so huge that the Fangtooth has evolved a special pocket in its upper jaw for them when its mouth is closed. But this extra effort is worth it. These massive needle-like teeth are very effective in capturing prey in the deep. With such sharp teeth, they can just snatch and impale slippery prey like small fish and squid and make sure that they won't escape. But with so little food available, Fangtooths are opportunistic feeders with a varied diet. They'll eat anything that they can catch, from small crustaceans to fish and cephalopods long. And they're found at depths between 2,000 and 2,600 feet, or about 600 to 800 meters, mainly in the warmer waters of the Pacific Ocean. And they've evolved some strange adaptations to survive in the dark. The weirdest of all are those tubular eyes, which point upwards inside its transparent head. This structure allows it to capture as much light as possible, which is vital in the deep sea, where there's very little sunlight. The eyes have large lenses that collect faint light, and this allows the barreleye to detect silhouettes and bioluminescent glows above it. At first, the eyes were thought to only allow upward vision, which raised the question of how the fish could detect any prey in front of it, and further research discovered another strange ability of the fish, that it can actually rotate its eyes forward, allowing it to look directly at potential food sources. But that transparent head, which is filled with a clear fluid, gives a number of advantages too. It protects the sensitive eyes from particles and debris in the water and may also help the barreleye detect more light by bioluminescent organisms, using their light to help navigate through the darkness. The bioluminescence from jellyfish and other organisms not only shows where prey might be, but it can also help avoid predators spotting their shadows before they've attacked. Alright, let's take a look at the Riftia. Riftia pachyptilla, which is more commonly known as the giant tube worm, is a deep-sea creature that's been discovered to live in one of the most extreme environments on the planet, hydrothermal vents. Found along the Pacific Ocean's mid-ocean ridges, particularly near the Galapagos Rift, these worms thrive around the boiling, mineral-rich waters that are released by these hydrothermal vents, where temperatures can exceed 600 degrees Fahrenheit or 350 degrees Celsius and are full of toxic chemicals. These Riftia can grow up to 8 feet or 2.5 meters long with a red plume that extends out from a protective tube-like shell. Now, this plume is not for breathing in the way that you'd usually think of, but it's designed to absorb the chemicals that are placed without sunlight or any normal food sources. The discovery of them in the 1970s completely changed the biological and ecological understanding of life on Earth. Until then, scientists believed that life could not exist without sunlight, let alone in places with such extreme pressures and toxic water. Riftia indeed showed that life could in fact thrive in the most extreme conditions, and this hasn't only changed the view of where else life could be found on Earth, but also where it may exist elsewhere in our solar system, such as on other planets or moons like Europa and Enceladus, where hydrothermal-like conditions might exist beneath their icy surface. Let's take a look at the gulper eel. Well, they're also known as the pelican eel. This is a bizarre species of deep-sea creature that's most recognizable for its oversized mouth, which can expand so wide that it's able to swallow prey that's much larger. Living at depths of between 1,600 and 9,800 feet, or about 500 and 3,000 meters, they live in some of the most remote parts of the ocean, and have evolved a series of eel's eyes are not particularly suited for clear vision at all. Instead, they're adapted to detect faint traces of light. As it lives in near total darkness, it relies less on sight and more on its other senses to locate prey, including its highly sensitive lateral line, which detects those vibrations and movements in the water. The gulper eel does, though, have a whip-like tail, which is long, flexible, and normally has a bioluminescent organ at the tip that glows with a soft pink or red light. This organ is thought to be used as a lure, attracting potential prey towards the eel's mouth in the darkness. By flicking its tail or emitting pulses of light, the gulper eel can tempt smaller creatures towards it, where they're more easily captured. Scientists believe that the gulper eels are solitary animals floating in the darkness and conserving energy until there's an opportunity to feed. This low-energy approach helps them survive in an environment where prey can be rare and where conserving energy is vital. The megamouth shark. That's another rare, bizarre species in the deep sea. It was first discovered in 1976 when one was actually arranged in up to 50 rows. And they're not used for biting, but instead for trapping prey like tiny plankton and small shrimp. Now, the megamouth has an unusual filter feeding method, which sees it swim with its mouth wide open, allowing water to flow in and through the gill rakers, which are comb-like structures. Once the megamouth has collected enough food, it closes its mouth, which traps the prey in there to be swallowed. Now, this feeding strategy requires very little energy, which is ideal for an animal that spends much of its time in the deeper, colder parts of the ocean. Another strange behavior of this shark is that it migrates vertically throughout the day, something that's known as diel vertical migration. During daytime, it generally stays at depths between 400 to 1,500 feet, or about 120 to 500 meters, but at night it rises to shallower depths close to the surface. This migration allows the megamouth to increase how much. Let's look at the viperfish. Well, this is a horrifying deep-sea predator with long needle-like teeth and a bioluminescent body. They're found at depths of up to 5,000 feet or about 1,500 meters, where sunlight barely even reaches. It's a great example of the extreme adaptations required to survive down there. They are, though, relatively small, reaching about 12 to 24 inches or 30 to 60 centimeters long in length. They've got a set of needle-like teeth that are so long they don't fit within the fish's mouth and instead curve back, almost reaching the fish's eyes. These teeth help the viperfish impale and hold on to slippery prey, which is an essential adaptation down there, where meals are rare and losing one can mean waiting days or weeks for another chance. Along its belly, the viperfish has light-producing organs called photophores, which create a blue-green glow that blends with the dim light filtering from above. And this bioluminescence has several benefits. First, it acts as a camouflage against predators looking up from below, as the light breaks up the fish.